Hey guys, today we will study about some of the types of the gear trains. First, the simple gear train. Well, this is a series of gear wheels in which each of the gears is mounted on a separate shaft. Here, all the gears will revolve about a fixed axis. Here, the first gear is known as the driver gear and the last gear is known as the driven gear. The intermediate gears are known as the followers and the remaining gears are known as idlers. It is important to note that if there are odd number of idlers, that is the odd number of intermediate gears, then the driver and the driven gear will both rotate in the same direction. And if there are even number of idlers, the driven and the driver will rotate in opposite directions to each other. Here the clockwise rotation is treated as positive and the anti-clockwise is treated as negative. Now, to find the velocity ratio of the simple gears. Well, considering gear 1 and gear 2, the velocity ratio can be given as n1 by n2 or z2 by z1. Considering the gears 2 and 3, the velocity ratio can be given as n2 by n3 is equal to z3 by z2. Now, multiplying these two equations, we have n1 by n2 into n2 by n3 is equal to z3 by z2 into z2 by z1. Hence, on simplification, we get the velocity ratio as n1 by n3 is equal to z3 by z1. Hence, from this, we come to know that the velocity ratio is dependent only upon the driven and the driver gears and is independent on idler gears. Next, the compound gear trains. In a compound gear train, each shaft will carry two or more gears except the first and the last shaft. The compounded gears are coupled to the same shaft and hence rotate with the same speed. Here also the clockwise rotation is positive and the anti-clockwise rotation is negative. Now, to find the velocity ratio for the compound gear train. Considering gear 1 and 2, the velocity ratio can be given as n1 by n2 is equal to z2 by z1. Considering gear 3 and 4, it can be given as n3 by n4 is equal to z4 by z3. Now, multiplying these two, we have n1 by n2 into n3 by n4 is equal to z2 by z1 into z4 by z3. Now, here, since the gear 2 and 3 are compounded, they will have the same speed. Hence, we can cancel n2 and n3. This will result in the value of the velocity ratio to be equal to n1 by n4, that is z2 by z1 into z4 by z3. Hence, the velocity ratio can be given as the speed of the first driver to the speed of the last follower. Also, it can be given as the product of the teeth on the follower to the product of teeth in the driver. Now, let us see why gear drives are preferred over belt drives. Well, compared to the belt drives, the gear drives will have a high transmission efficiency. Also, the gear drives can be used to transmit motion over small center distances of shafts, unlike the belt drives, which cannot be used for this purpose, as will lead to a reduce in its tension. Also, the gears can be used to transmit motion between non-parallel intersecting shafts. Also, the gear drives are the most compact compared to the belt and the chain drives. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.